Okay, a skier going down a hill may be concerned with the steepness, Bailey, of this, of the what? Of the ski hill. Okay, so skiing. That's skiing, but it's not as fun as that skiing, right? And if you're good, maybe you can like ski that. And if you're crazy, maybe you try something like that. Okay? How much steeper can I make this line? Could you ski that? No, that's called free falling. Okay? Your skis aren't on the snow anymore. You're just falling towards Earth at 9.8 meters a second squared. Can you ski that? Yeah, that sucks. Okay? That's boring. If you like it, fine. Okay. But what are we talking about? The steepness of these lines. That is what slope is as a definition. Okay? It doesn't just happen in ski hills, roofs. Some roofers out there, some of them haven't even been through grade 10. Okay? They dropped out in grade 9, started working at the age of 15. Okay? And they're still a roofer at the age of 70. They have no idea about grade 10 math. But tell him, today you're going to do a 3/8 pitch roof. And he's like, oh, sweet. He knows what it means. Okay? Because that's a roof that kind of looks like that. Okay? Not too steep. That's okay. 7/8 pitch? Oh. Okay? 7, 8, little bit longer. Well, that's almost like a 45-degree angle, isn't it? He's going to be wearing his harness on that roof. Okay? Steep. Not as fun as doing like this. And at some pitch, I don't know what it is, but if it's not steep enough, well, then you can't even use shingles on it. They're only designed to shed water up to a certain angle. If this angle, okay, is too small, well, then they got to use tar and gravel roof, right? Flat roofs, they still have like one on our ceiling right above you. It's a flat roof. Can't use shingles. Water just comes in between them and it leaks. Got to use tar and gravel, continuous membrane. Okay? But my point is, these guys, they throw these numbers around like, you know, they know it's slope. They understand slope very well. They're on a slope all day long. Okay, so what is slope? Those two numbers I gave you, that's a vertical number, 3/8. Okay, that's the vertical part. 8 is the horizontal part. Vertical over horizontal. That tells you how steep it is. That's the rise over the run. Okay? Vertical over horizontal. That's what it means. Rise over run. Rise kind of makes sense, but run, not so much for horizontal. Just something you're going to have to stick in your noodle. Okay? All right? So this, I don't find that helpful. We want to write something else here. Ah, thank you. Slope is positive if top of the line or line segment tilts to the right. And I'll draw a little picture on that in a sec. Picture's worth 1,000 words, right? What do they got? The rise is positive if we count up and negative if we count down. Okay, you know what? I've read that 100 times. I still don't know what exactly they're talking about. But if you think it's useful, use it. So, slope, that's when it's positive. It is negative if top of the line, well, what's the opposite of right? If it tilts to the left. All right, so examples of positive slope. Here's your graph. right? X is always your independent on your x-axis. Y is always your vertical, your output, your range, whatever you want to call it today. Here's a line. The top of the line there tilts to the right from vertical. Okay? So if I pull out my ruler, that's vertical. You see how that tilts to the right? That's positive slope. Anything from just off vertical all the way down to just off horizontal, because here, again, we know that's cross country, right? Not a very good slope. That's all positive. So there's one example. Let's draw another line. Let's say this one over here. Okay? That's a positive slope. That's a positive slope. Okay, those all tilt to the right. You know what I'm saying? Does that make sense? All right. So, something that doesn't, let's put it in blue. If it doesn't tilt to the right, if I go perfectly vertical, don't draw that, but just tilt it a little bit that way, that tilts to the left. That's negative. It's just what we call negative slope. Okay? That's negative. This is negative. Anything just off a horizontal is negative. Those all point to the left. The top of the line points to the left. There's another definition, is it on the next page? Yeah, okay. But a picture's worth 1,000 words, right? I'm not going to ask you in words what it means. You just got to know, looking at a line, if it's got a positive or a negative slope. Okay? Each line segment has endpoints with integer coordinates like IE. There's the coordinates of E, there's the coordinates of F. Complete the table below. Segment AB, there it is. What is the rise of this run? Run? What is the rise of this line? What is the rise of this run? Okay, rise is how far vertically the end is from the beginning. Okay? There is no beginning and end here. I can take the right as the beginning, and then it'll fall as we go from left to right. Okay? You remember that Pythagoras stuff yesterday? That's all you got to do. Make a triangle. Now can you see how many units of rise this line has? It's got 1, 2. The run must be then the horizontal. You only got 2 choices here, right? Okay, that's 1, 2, 3, 4, 5, 6, 7 units for the run. Slope, by definition, is rise over run. So slope, by the way, that's the symbol for slope. It's M. Might as well start using it now. Rise is 2. Run is 7. That's 2 7ths. Don't make it a decimal. Just like x and y intercepts, we want to leave it as a fraction, okay? Because roofers don't know decimals. Okay, whatever that is, 0.17, he's like, huh? Give me that as a fraction. 2 7ths roof. Oh, okay, cool. That's a nice roof to work on, okay? Not too steep. CD, rise. Make yourself a triangle, okay? And does it matter if I make it there or make it here? Is the rise the same in both cases? Yeah, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Doesn't matter where you go. What's the run? 1, 2, 3, 4. Okay, if you count on the top, it's still 4. So my slope is 5 over 4. Kids good in fractions will notice that's bigger than 1. That thing must be greater than 45 degrees. Okay, pretty steep roof. You're going to want to tie yourself onto that roof because it's pretty easy to fall off, right? It's called the harness. EF. What do we notice about the difference between EF and those other 2 lines? Yes. Yeah, but first, what's the rise? Make yourself a triangle. 1, 2, 3, 4, 5. Rise is 5. What's the run? 1, 2, 3. Okay, so my slope is, leave a little space, just in terms of numbers, it's 5/3. but that's a negative slope. So we want to put a negative here, okay? These other two tilt to the right. The tops of the lines tilt to the right. This one tilts to the left. So that's a negative slope. Yes?
I feel like this is trigonometry.
Yeah, it's all right angle triangles, isn't it? Yeah. And it's related, isn't it? How steep the line is means how big the angle is, right? That's as steep as you can get. What's the angle here? 90 degrees, right? Not quite as steep. We know that's pretty close to 90 degrees. Let's say it's 89.9, right? I can do trig with this one. I can't really do any right angle trigonometry with that guy. All right. Investigate. Investigation number 1. This is a line. It's all broken up into line segments. Speaking of trigonometry, do you remember this one in trig? That was the first example we did. How does the angle of triangle AB compare with triangle AC, compare with triangle AD? How does that angle change? It doesn't. It's the same. What are we going to think about the slope here? Well, let's figure it out. Let's AB. Look at it. What's the rise? 1, 2. What's the run? 1, 2, 3. My slope is 2/3. Okay? I know some of you know that's 0.66 repeat as a decimal. Who cares? The slope's 2/3. Leave it as a fraction. Let's look at AC. What's the rise? 1, 2, 3, 4, 5, 6, 7, 8. What's the run? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This slope is totally different. It's like 8/12. Can I reduce that? 4 goes into 8 twice. 4 goes into 12. Were we expecting this? It's the same slope, isn't it? Guess what AD is going to be? Yeah, same slope. It's the same angle here, right? This is just as steep as this. It's just as steep as that. Any line segment on that line is the same slope. It has to be, by definition. Okay? Slope. Rise over run. All you need is 2 points to make a line or a linear relationship. So, let's look at horizontal and vertical lines. Like I said, if you're a downhill skier, this is torture, right? If you like cross country, and some people do, hey, feel free. Some cross countries actually go uphill too, right? That's way too much exercise for me. Exactly. All right. What's the slope of line AB? What is my definition of slope? Slope is rise over run. What's the rise of a horizontal line? It does not rise at all. What is 0 divided by anything? 0. Let's just count it anyway. 1, 2, 3, 4, 5, 6, 7, 8. Put that in your calculator. I don't care how long the line is. Let's come to a conclusion. What is the slope of any horizontal line? 0. Boring equals 0. Okay? Any horizontal line. Memorize that. Okay? So 0, 0. Now we get to the tricky one. Let's look at GH. Slope, by definition, is the rise over the run. What's the rise? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, what's the run? Yeah, how far horizontally does this line change from this point to that point? It's the same x point, isn't it? X is -6 here, x is -6 there. How many times does 0 go into 10? Tyrell. Let's find out. Let's see what my calculator says. It doesn't know. It's not smart enough. Does your calculator do it any better? Is it any smarter? Try it. I don't care what number you use. Try anything divided by 0. Error. We don't know how many times 0 goes into 10. When I was your age, we would call it infinity. A bunch of professors got together and had a big meeting for a year and a half and decided, I don't want to say that anymore. Let's use the word undefined. Okay? Because we don't know how many times 0 goes into 10. The slope of any vertical line is undefined. Okay? Can't do it. That's another way to say it. All right? Memorize that. Should be an easy mark on the test. Horizontal line, the slope is 0. Should be an easy mark. Okay? Horizontal line segments have a slope of what? 0. Vertical line segments have an undefined slope.
Why wouldn't we just call it 0 slope?
Because they're totally different. 0 is not undefined. It's 0. That's fine. Right? Infinity. What's infinity? Right? It's different. It's totally different. Okay? All right. Positive and negative slopes. I don't think we need to do all these. I'm going to give you guys lots of time to finish this stuff today. Line 1. Let's find the slope of this line. Now, what if the endpoints are hanging here in the middle of nowhere? What's the coordinates of that? I have no idea, so you don't use it. That's why we gave you this example here. Does it matter where on this line you find 2 points and take the slope of? It's going to be the same irregardless, right? So you got to find 2 nice points. To stop. Ah! Okay. Whoa. There's one. Keep going. Up. All right, there's another one. And you know what? That's the only 2 on this line where you know for sure what the coordinates are. You can't use anything else. You can't assume, oh, that looks, that's about a half. Sure, it's about halfway. Don't. You can't. Because how do you know it's exactly 1.5? It might be 1.52. It might be 1.49, right? You don't know. You got to use this one and this one. Make your triangle. What's the rise? 2. What's the run? 3. Then you got to double check. Is it a positive or a negative line? Does it tilt to the right, the top?
Yeah.
Yes. So it's positive 2/3. Okay? Let's go over here and look at line 5. You see a couple of nice points on there?
Yep.
Do it in your book. Huh? Where's 2 nice points on that line you can find slope from? Find it. Line 5. Okay, that's where I got my triangle. What's the rise? 1, 2, 3, 4, 5. Oh, this is line 5. What's the run? 1, 2. Everybody agree? And what do we got to do?
Put a negative.
That's a negative slope. The line goes, looking for you guys, it goes like this, right? Tilts to the left. Negative slope. So you got to put a minus there. Actually, this is a good time to review this. Is this the same as this? Yes. Is that the same as this?
No.
Yes. They're all the same. Put it in your calculator. What is negative 5 divided by 2? Negative 2.5. What is negative bracket 5 divided by 2? Negative 2.5. What is 5 divided by negative 2? Negative 2.5. Okay? It's all the same. It doesn't matter where you put the minus here. Okay? All right. Here's another definition for slope. A line which rises from left to right. Okay, let's look at a line that rises as you go from left to right. If it rises, is that positive or negative, Alicia? Positive. So that's another way to define this, okay? That's better than that gibberish they had at the beginning. So, you know the answer here. If you know one, you know the other. There's only two choices, but let's do it. A line which falls from left to right, that's definitely negative, isn't it? Okay? But 99% of us, this is just a visual exercise. Just look at the line. If the top tilts, guys, if the top tilts to the right, like the blue one, that's positive. Okay? If the top of the line tilts to the left, like the green one, that's a negative slope. Okay? This one's too confusing. I keep explaining that 4 times every year because it's a hard picture to understand, so don't worry about it. All right. 2 more. Draw a line segment on the grid which passes through this point. We all know how to plot that point. Negative 4 and 2. First, always check your grid. You don't assume each line's a 1. Here it is. Okay, negative 1, 2, 3, negative 4. Positive 2. That's right there. This line has a slope of negative 2/3. Draw the line. Do you know how to do this? What does the slope mean again? Slope is rise over run. So from that point, you go 2 units of rise, 1, 2, and 3 units of run. But which way do you go? You're going to want this line to look like this because it's negative. So I want my 3 units to go 1, 2, 3. I want them to be over there. Okay? So I could go 1, 2, 3 that way, or 1, 2, 3 this way. If I put my point there, that's not negative slope. That's positive slope. So I'm going to want to put my point 1, 2, 3 units there. Okay? There's a line. How many points do you need to do a line? 2. Okay? That's all the information you need. There's the line. How can I check to see how good I can draw a straight line? Here's another question. What happens if your point was way up there? How do you go 2 units of rise there? Is this also 2 units of rise? Yes, it is. And 1, 2, 3 units of run. Look at that. There's another point on the line. Okay? Because it does say write the coordinates of 3 other points on this line. There's another point. 2 units of rise. 1, 2, 3 units of run. My line was a little off there. Should have went right through that point. Okay? 2 units of rise. 1, 2, 3 units of run. Let's do another one from where we started. 2 units of rise. 1, 2, right there on the edge of the grid. There's another point. Does it kind of look like they're all in a line? Does it kind of look like a linear relationship? Okay, which ones do you want to pick? Doesn't matter. Let's pick that point. That's 5 and negative 1, 2, 3, 4. That's another point on the line. So is this one. 2, negative 2. And let's use this guy way over here. Negative 5, 6, 7, 8, 9, negative 10. And 1, 2, 3, 4, 5, 6. Okay? Any questions on that? It's an important question. Worth lots and lots of money on your test. Yeah. Okay. So really, when you're doing this, guys, because our test is what, in 4 school days on this? We'll be doing it again. Slope, I'm going to say about 50 times in the next 20 school days. That's all you have left in the semester. 20 exactly after today. Okay? This one's a little trick here. Last one, so pay attention. A line segment has a slope of -5/7. What is slope? Slope is -5/7. Slope is rise over run. It's telling you what the rise is. The rise is 12. What's the run? I got 2 equations there. One's all in words, one's got a couple of numbers. If the slope is equal to this, and the slope is equal to this, then this is equal to this. There's an equation. You can solve an equation if you have only one variable. I have 2 variables here. I got to know one of them. The one I know is rise is 12. That's where you put 12. Okay? Then you can solve it for run. This is good old substitution, right? So 12 over the run is -5/7. That's an equivalent proportion. How would you solve that? Remember cross multiplying? Okay? This times this, -5 times run is equal to this times this, 12 times 7. No more denominators. Okay, how do I solve this for the run? That's my variable, isn't it? I know it's got 3 letters there, but that's what I'm solving this for. If you like, make it an x. Solve for x, doesn't matter. Divide both sides by -5. My run is equal to, what's 12 times 7 divided by -5? But we don't want a decimal, do we? It's -84 as a fraction. Okay? That's what it is. Don't make it a decimal, just leave it like that. That's what the run is. Okay, it's an ugly run, but it's still an answer. All right, so just write stuff down. You know that, make yourself an equation. Sit there and look at it and don't write anything. You'll still be sitting there and looking at it 10 minutes later, right? Lots of times guys go, oh, I don't know, what do I do, And I just say, just write it out. And they start writing it, next thing oh, okay, yeah, right? Write something down, figure it out. Okay, 1 to 4, 6, 9, 9 to 11. Okay, this test again is going to be Thursday, guys. All right, that's like 4